Okay, let's go ahead and start with section 4.5. This is actually the last section in this chapter. So after today, I don't have so many books on my desk. I think I need to get to the next page. I think you just have, yes, okay. Yeah, you'll be taking the quiz after this section. Okay, so let's go ahead and take a closer look at negative numbers and fractions and see if we can do these two things. Observe how the consistency of division that God created and sustains works with fractional notation, and to apply this consistency to problems that we can otherwise solve. So let's consider this example involving negative numbers and an unknown. Okay, the example is x minus negative 50 halves equals 15. Okay, complete division of negative 50 halves is, okay, x minus negative 25 equals 15, because this is negative 25. Okay, negative 50 divided by 2 is negative 25. Here we have two negative signs that make a positive, as we have the opposite of the opposite. Okay, so x plus 25, because it's the opposite, equals 15. Subtract 25 to both sides of the equation, and we're left with x equals negative 10. Now in this example, we could simply complete the division, negative 50 divided by 2, getting negative 25, and then solve it. But what if we had a different fraction? One that wouldn't get a whole number if we divided. Let's say that we had x plus 4 over negative 5 equals 15. How could we solve this without rounding the answer? So we're going to backtrack for a moment. So 4 over negative 5 means 4 divided by negative 5. We've already seen that since each negative sign means the opposite of, if we are dividing with one negative sign, we end up with a negative answer, the opposite of. But if we have two, we end up with a positive answer. The opposite of the opposite is a positive. We keep bouncing back and forth from positive and negative numbers. Okay, so this right here written in black and bold is very important. In fact, if we have an odd number of negative signs, we get a negative answer, while an even number of signs gives a positive answer. So even though we don't want to complete the division right now in 4 over negative 5, we know that since there's only one negative sign in this, the answer will be a negative. So we can safely pull the negative sign out in front of the fraction like this. Okay, because we know that there's, now if this one was a negative, it would be a positive, but we know there's only one, so that's odd, so the answer is going to be negative, so you can just pull it out in front of it. So making it negative 4/5, as the negative will apply to the result when we complete the division. Remember, 4 over 5 means 4 divided by 5. All right, let's look at the next page. Here's an example. X plus 4 over negative 5 equals 15. This was our example. So we're going to move the negative sign in front of the fraction, as we know the result will be negative. Now we can solve for our unknown by adding the additive inverse, in this case 4 over 5, to both sides and then simplify. Okay, so the additive inverse of this is not 5 over 4, it's positive 4/5. Okay, and then we can pull it over and we can do all of our calculations. Note that we can move a negative sign in front of a fraction even if there's already a negative sign there. Let's look at this one. X minus negative 1 over 5 equals 4/5. Move the negative sign in front of the fraction, as we know the result will be negative, because right in here in this division your answer will be a negative because there's only one, so they're pulling it out in front of it. So here we have x minus negative 1/5 equals 4/5. Simplify. Since the opposite of an opposite is a positive, the two negative signs can be replaced by a positive sign. So then you're left with x plus 1/5 equals 4/5. Now, When I was in school, and I think I've already said this, my teacher used to tell me when it came to subtraction of negative numbers, that what you always wanted to do is you always wanted to change this to a plus and take this second number and get the opposite of it. Well, the opposite of negative 1/5 is positive 1/5. So that means right here they changed this to a plus and took the opposite of this. So that's what you would do. Okay, so you're adding the additive inverse is basically what you're doing. Okay, so then you can do your calculations. Right here they took away 1/5 from each side, negative 1/5. And they came up with 3/5. Now let's consider another problem, this time one that has two negative signs in the front, like this one here. Because we know that a negative divided by a negative equals a positive, we know that negative 2 divided by negative 3 will be a positive. So we can remove both of those signs, leaving us with just this. Now we can easily solve for x by adding the additive inverse, in this case, negative 2/3, to both sides, and then simplifying. Okay? All right, so let's look at the final example. When you encounter problems with negative numbers in a fraction, remember that the fraction represents division. Then use what you know about dividing negative numbers to solve the problem. Each negative sign means the opposite of. So one negative sign means the fraction will yield a negative answer. Two negative signs means the fractions will yield a positive answer. So one negative sign up here, this one, so you're going to get a negative answer. Here's 1, you're going to get a negative answer, but here's 2, so you're going to get a positive answer. Okay? All right, here's 1. X minus 2 over negative 3 equals 5. All right, move the negative sign in front of the fraction because you know it's going to result in a negative. Okay, so here we're left with 2. So then you're going to change this to a plus and take the additive inverse of this. We have that. Then we're going to solve for the unknown by taking this number and you're going to add the additive inverse. In this case, the additive inverse is negative 2/3 equals 5 plus negative 2/3, which gives you 4 1/3. Because you subtract, but it's positive, I guess is the best way to put it. Okay, this one's a little bit confusing even to me, so I was never really good at negatives and positives, so that's okay. We'll just learn it together. Okay, you can use a calculator on this worksheet whenever you see this symbol it says, so make sure you have one available. I think it says that on every one of them. Negative numbers and fractions. All right, simplify 1a, 1b, and solve 1c through 1g. Leave all answers as either whole numbers, mixed numbers, or proper fractions. Okay, so A, the example meaning might be 80 pounds of force in a negative direction distributed over or divided by 40 square inches. And here's kind of a picture of what this is. So now remember it says to simplify 1a and 1b. So what we're going to do on this is, let me make sure. Okay, yeah, on this one to simplify, like I said, is just a fancy word for answering it. These down here are equations that we have to answer, so it's kind of the same thing. Okay, so negative 80 divided by 40. Now there's one negative, okay? So what is that going to leave us? Remember, these can cancel each other out, so that's going to leave us a negative 2. Since there's one negative, remember oh my gosh, what am I trying to say? An odd number of negatives are going to give a negative number. Okay, so on B, we have 40 minus negative 16 over negative 8. I want to make sure I'm showing you these correctly because, like I said, I'm not really good at these. I think I've got them, but I think I've done a little too much math today. I need to take a break. All right, so yes. Okay, so what we're going to do on B is, now this right here is going to simplify to what? Negative 16 divided by negative 8. That's two negative signs. So that's an even number. So that means you're going to end up with a positive. So you're going to end up with 40 minus your positive 2. So your answer then would be 38. All right. Now let's look at C. All right, on C, now right here we've got 1, so we know that it's going to end up this way, minus negative 39 over 40 equals X. All right, so then what we do is we're going to rewrite this. We're going to change this to a positive, or to a plus, I mean. Take the opposite of this, which is positive 39 40ths, which equals X. Okay, so then what we do is we add these together. So then 70 plus 39 40ths gives you 70 and 39 40ths, and that equals X. Okay? All right, let's see if we can do this one. I'm going to have you do these last three yourself and just see if you can do those. All right, this one has 1, so it's going to end up being written this way. Okay, we're going to go through here. We're going to change that to a plus. Take the opposite of this, which is 25/10 positive. Now, your answer then would be 60 whole plus 25/10. But now, 25/10 can actually be simplified down because 25/10 is improper. So we need to see how many whole times can 10 go into 25. 2 whole times, right? So we'll need to add that 2 whole to this. So that's where we get our 62. Now, when it goes in there 2 whole times, how many would be left over? It'd be 5/10, right? Oh, why did I put that equal sign there? I'm adding these up. Okay, so then you're left with 5/10. Well, 5/10 is actually 1/2, right? Okay, so you'd simplify that to 1/2. So your answer then would be 62.5 equals X. Okay, all right, I want you to go ahead and pause it and see if you can do E, F, and G, and then I'll give you the answer just to make sure you got these right. Okay, on E, you should have gotten X equals 10 and 2/21. Okay, on F, you should have gotten your final answer would have been X equals 30. That one simplified down real well because all the numbers were pretty much whole numbers. And then on G, X would have been 60.5. Okay. Now it says to go back and check your work for problem 1G by substituting the value you found for X into that equation. Did you find the correct value? Show your work. Be sure to also check any other problems you're unsure of. Okay, so this one, we got 60.5 for X. So basically, you're just going to rework the problem. You're going to take 60.5 and put it here and subtract 39 over -2 equals 80. And then just work the problem and see if it comes out to be 80 equals 80. It should, because this is the correct answer. Okay, Now you will have to make your numbers. You will not have to make them improper. That's only when it's multiplication and division. You will have to have common denominators, though. If you don't, you may, but anyway. So you want to go ahead and try that one. Okay, so then on the back page, while the Egyptian pyramids had squares for bases, pyramid shapes can have different types of polygons for bases. The pyramid has a base made of the hexagon below and a height of 54 feet. What's its volume? You can still use the same volume equals 1/3 times the area of base times height formula. So I want you to go ahead. You're just using the formula. You're just plugging in numbers, okay? And then you've got some skill sharpening down here to solve. All right? If you need any help, let me know and I'll be happy to help you on all this, okay? Now when you're finished, you can go ahead and read through, and you can do this tomorrow or today, it doesn't matter to me. Just read through the chapter synopsis. It's real short. It's like half of a page. Just read through it to say, you can say that you read through it, and then you'll be ready to take the quiz, which is quiz 3. So when you take quiz 3, you'll be ready to start chapter 5. So that's all for today.